I am wiring up this 2-speed constant torque motor. Well, actually, I'm not wiring it up, I'm unwiring it. And why am I unwiring it? Well, this system is pretty old, and I don't trust these switches, even though they're super awesome. They're switching 3-phase power, and some of this is a bit schwanky, and I can do a little better. So this motor has 6 taps. And why do I say taps? Well, it's a 3-phase motor, and it can be wired in 2 ways because it is a 2-speed motor. It can be wired as a low speed, high speed. So in low speed they do 1, 2, 3, and in high speed they do 4, 5, 6, and then they bond together 1, 2, 3. Googleizing, you find a couple of things. So this is considered delta, and this is considered Y. So in delta, it's a triangle where all of these phases, all of these windings form a triangle. And in here, what you actually do is you fold the triangle into itself and you feed it from a different point. Well, what does that actually do? So how did I deduce this? First off is, well, you trace it. So line 1, line 2, it goes to this switcher. This switcher, what it does is it flips the phase of 2 of the pins. So in one position, these huge contacts go ka-chunk, ka-chunk. So it shorts these 2 and it shorts these 2, and in this situation it just goes straight through. Well, what does that actually do? Well, in a 3-phase motor, all you have to do to change its direction is flip 2 of the phases. So in this position, I have 2 of the phases actually reversed. So I have a line coming in, I have a line coming in, and it feeds a winding, and it feeds a winding, and that's how you reverse it. That's easy. Where it gets complicated is this multi-position selector switch. And what it needs to do is it needs to accomplish this. So it needs to take those 1, 2, 3 lines that come from my direction box and feed it towards the motor, and it needs to change windings. So it needs to short a bunch of windings. So you go back and forth, and okay, so I gave these arbitrary names. So I knew that my input was coming here, because in the middle off position there is, it's open, so there's no contact with the motor. Had to disconnect the motor because it's delta Y. So I figured out where each one of these contacts were, and where each one of these, oh yeah, that's where it makes contact, and I drew that. So here I drew, well, here only, the line coming in connects to this pin, and here it actually loops to a different pin, but it also bonds 432 together. So I know that is my high speed because of my delta Y. So in this position, you can see this one is bonding 1, 2, 3 pins together, and there's this little jumper bar at the bottom, and these 2 are constantly bonded together. So in this situation, I have windings 1, 2, and 3 jumpered together, and then I'm applying power to this one, applying power to this one, and applying power across here. So I know that kind of figures this out, but I didn't know exactly how this delta Y worked. So I started doing some measurements. So I measured pin, well, in this case they call them, I think they call them terminals. So all of these have these little metal embossed terminals. So I would measure 1 to 2, 1 to 3, 1 to 4, 1 to 5, 1 to 6. 2 to 1 was actually already done, so I didn't actually need that. 2 to 2 doesn't exist. 2 to 3. So I got different measurements between these. So I got 6.2, 3.8. Oh, well, 3.8 plus 3.8 is roughly 4 and 4, which is roughly this number. So I know that this is actually, well, in this case it's a winding. So let's just call this, for the sake of argument, 3, and let's call this one 4. So if I measure this midpoint, I measure 3.3 and I measure 3.8, but if I put them in series and I measure this to this, I get 6. So by deducing all of these calculations, what I came up with was, okay, so this is really easy. You start, well, I know that 4, 5, and 6 are my outside ones. So I wanted to find something that straddled 4 and 6. So I go over here and I go, well, 6 and 4, sorry, that was 3 ohms here and 3 ohms here. So 6 and 4 I know is, 6 or 7 ohms. But 1 to 4 is 3.8. And I go, okay, well, 1 to 4, so what is 3 ohms to 6? So here I go, 1 to 6 is also 3 ohms. So I go bing, bing, and here I've found that this is terminal 1. So 1, 4, 6. Okay, that's awesome. Deduction, kind of like Sudoku. Well, this is obviously going to be a 5. So 5, 6, and 2. So I go to my 2's and I go, well, there's 5 and there's 6. So I go, okay, well, that one's good. Process of elimination, pin 3. So pin 3 should between 4 and 5. So 3, 4, and 5. And that's what I measure. So that's how I'm able to find that I have this delta in that way. So what is it actually doing when I fold it? So if I put 1 in the middle and I put 2 in the middle and I put 3 in the middle, well, what I actually have is, well, I have 1 that is actually like this, 1 is like this. Okay, so I have 1, 2, 3 in the middle, and those are all bonded together. And if I have 1, 2, 3, then I would have 4, 5, and 6. So what happens when I put all of these together? So if I folded this in the middle, what I would have is I would have a resistor, 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 resistor. So it's actually like this. So these resistors are actually in parallel with one another if I bond these together. So I actually did this experiment. So I put 1, 2, and 3 together, and sure enough, I get 3 ohms and 3 ohms and 3 ohms. So if I fold this in, so terminal 4 actually has resistors 1 and 3. Terminal 5 actually has resistors 3 and 2, and terminal 6 actually has resistors 1 and 2. So if I put all this together, this is actually what it looks like when they're in parallel with one another. Whew. It's the reason I'm pulling this apart is I want to replace this motor and replace all this electrical, but never pull apart things that you don't fully understand. And it could have been really bad if somebody, just cut the cable. But this little plate, this little placard, was kind of a very, very important thing in order to ensure that I could actually document this. I have confirmed that this is how these switches actually work. But these switches are, they're pretty greasy, they're pretty oily, and I do want to clean them and I do want to refurbish them a little bit. But I do think that what they're going to do is ultimately drive a VFD, which drives this. The one thing about the VFD, which is kind of not going to do exactly what I want, this delivers constant torque at a low speed and a high speed. So if I do a VFD and I choose one of these two, I don't have a constant torque. How big of a deal is it? It's a big deal on a lathe. You want a constant torque at high speed and low speed. But on a VFD, in order to switch between those two, I would need some pretty heavy-duty relays in order to make that switch happen. So if I wanted to go from high speed and have a variac in between the high speed from 0 to high, and then low speed 0 to max of low speed, max torque, I would have to have a gearbox that essentially emulates this. Not hard to do. You could probably do it with, well, here they did it with 1, 2, 3, 4, 5. So you could probably do it with 5 relays. Same thing with the speed. You could probably do that with 3 relays. Well, you don't even need 3 relays. You just need 2 relays actually. So in this case, it wouldn't be too hard. Is it worth it? I'm not sure yet. That's more math to do.